So, as the next part in KNX chapter for HVAC in advanced course, we are going to see what book said. First of all, it says, in a large functional building, as a so-called management level should be used. It means we should utilize the data not only from the rooms but only from the mechanical rooms, and let the mechanical rooms to be worked in relative to the rooms to control HVAC. This management level checks and visualize all the processes in the building and links various bus devices together if required. Apart from KNX, DDC systems, direct digital control, special security system, lift control and entry systems can also be used, for example. These systems then interface the management level via the gateway linking elements between the various bus systems. So, what book said? Consider we have the mechanical rooms. It is possible to have the digital input-output, analog input-output between the installed KNX systems in rooms and mechanical rooms. Also, we can replace this digital analog input-output with gateway, of course. So, if we install it with gateway, so we have the data in bit and byte to control the boiler and so on. You can see here the picture. So we have two ways at least. Or we can have some controller with KNX directly to the mechanical room devices. It is also possible. So the point is, the book is not going to go detailed to control to how we should control the boiler, chiller, pump station and so on to provide all HVAC in mechanical room, but only mention that there is a possibility to do that. So let's go to the fan coil unit that we are going to study more. So you can see here we have different type of fan coil units that can be installed or placed on the floor or in the ceiling or with inside controller in the ceiling. We have the different type of fan coil. It is so important to know the different type, because when you want to control it, you should first of all you should know what sort of fan coil unit you have in a project. Then you go and select the right actuator for that. You can see in the picture the 4-pipe fan coil unit. We have the heat and cool supply to each fan coil unit, and then we have the return flow. Also, all fan coil unit can be networked through the net KNX by the KNX actuator we have. So first of all, what is the fan coil unit structure? You can see we have the fan and coil. So we have the coil and we have the fan. In coil, the hot water supply or cold water supply for winter and summer, and there is a return from each of them to the mechanical room. So first of all, we have the 4-pipe fan coil unit that the supply and return are differ. Then we have the 3-pipe when the return is the same for both hot and cold. And we have the 2-pipe control, that is a simple one, and supply for hot and cold is the same, and return for both of them is the same. So for example, in ABB catalog you can see we have the different type of fan coil actuators. One is for fan coil with output for 2 valves. It supports 4 pipe fan coil units, and 3-speed fan. One is with 0 to 10 volt to control the valve and 3-speed fan, and one is to control the 3 with output 3 of the continuous output 0 to 10 volts. One is 2 pipe, 1 PWM to control on-off valve and 3-stage 3-speed fan. One is with 2 PWM to control the valve and 0 to 10 volt DC to control the fan in a continuous way. The room temperature with relay output inside, the blower actuator to control the only fan without valves, and some specific solution from the ABB company. So you can see, if you have the project, first of all you should understand what is the mechanical structure of your fan coil, and then go and find the right fan coil actuator. Your question will be, is it 4 pipe, 3 pipe, or 2 pipe? Is it equipped with valve? Which type of valve it used? On-off or continuous one, or 3-way valve? And then you should ask the question how the speed should be controlled. Is it a 3-speed control or 0 to 10 volts DC control type for fan speed, and so on. Yes. Okay, great. About the KNX integration. So, how the fan is controlled in the fan coil unit. Look, we have 2 types of control for the fan when you set the parameter in ETS. One of them that is popular is the interlock one. It means when the output 1 for speed 1 is on, so for sure the output 2 and 3 is off. When the output 2 is on, for sure the output 1 and 3 is off. And when the output 3 is on, the output 1 and 2 is off. So this is the interlock one. Okay, in this case, for this type of AC motor, if 2 outputs is on at the same time, you lose the motor. Another one is the accumulation type. So this is the interlock. The next one is accumulation. In accumulation type, if the speed 1 is on, for sure the speed 2 and 3 is off for speed 1. In speed 2, the speed 1 and 2 should be on. In the speed 3, the output 3 is off. For speed 3, the 3 output should be on. You can set this in a parameter of ETS. For example, if this is my project, if I go to the parameter for actuators, in a fan coil actuators, in a fan, you can see here it is asked from me that relay management type, is it switching only one relay for each speed or accumulation, multiple relays on. So you should set this parameter according to the book. Of course, there is operating mode, the comfort, standby, night, and frost. This is the predefined set points. Okay, for most of the time by default it's based on ASHRAE. So if we want to see it, we should go to the thermostat. In a thermostat we have the set point part. You can see in the set point part we have the set point for comfort for cooling mode, standby, economy, and so on for cooling. Also the comfort, standby, economy for heating, and protection during the freezing or overheating. Okay, we have some numbers defined by the manufacturers by default. Of course you can change it if you need it. Yes. So sensors such as presence detectors, time switches, room thermostat, humidity sensor, window contact, or sensors for condensed water, as well as binary input which influence the controller, can either communicate with KNX directly with the fan coil actuators via the group addresses, or alternatively sensors can be connected directly to the actuators. It depends on the respective device, whether it's just an actuator or an integrated control unit. So please note that during the controlling of the fan coil unit, the simple one is we have the thermostat with temperature sensor inside and fan coil actuator to control it. But sometimes we have more items: digital input output, analog input outputs. How? Maybe we want to act for actuator of the fan coil based on humidity, to reduce or keep the humidity in some sort of level. Okay, maybe we have the some output to the drain tank of the fan coil units that is coming from the fan coil actuators, or some level controls that trigger it with the input, digital input, right in the fan coil actuator unit. So we have some other controls based on our needs. For example, we have the carbon dioxide sensors, and we want the fan coil actuator units work based on carbon dioxide to keep it low. So we should consider it case by case, but it's not so popular, but it is in the market, so we should take care of it and read the manual. Always read the manuals. So, for example, we want to control the fan coil unit with 3-speed fan, open-close fan coil valves. Okay. With the fan coil actuator, these fan coil actuators provide us the outputs to control the fan valve and the inputs from the window, and we have the thermostat with a button inside of it and temperature sensor to make the fan coil on off, control the set point, change the mode, heat and cool, control the manual auto fan speed, and be able to control the fan speed in manual way. You can see here the wiring. Here this is a fan coil unit, 4-pipe fan coil unit. You can see it. This is a fan. You can see the line from the city is coming to the fan coil actuator. There is 3 output 1, 2, 3, speed 1, speed 2, speed 3 to the fan, and then also you can see there is 2 output for the valve, V1 and V2. It's coming to control the 2-point valve for the heating coil and cooling coil, and also there is input from the window side. This is a thermostat. In thermostat you can see the pictures here. This is the on-off air condition or fan coil. This is a plus and minus to control the set point. This is the button to control the manual fan speed and change it to auto, because when you go to speed 1, 2, 3 by manual, the thermostat is going to be in manual mode. You should move it to the auto mode, and also the button to control it to the for a special mode. You need it. And also this is a power supply unit from the KNX devices. So this is a test bench. What's happening? We have some link between the sensor, the thermostat that is most of the time is inside of this keypad, and fan coil actuator. Okay, so you can see the link to on off the thermostat and fan coil is simultaneous link between these 3 parts. For set point, this is the only link between the keypad as a sensor and to the thermostat. For the fan coil speed control, for the manual fan coil speed control, this is the link between the room controller and fan coil actuators, you can see it. Okay. An important link is here. You can see the value control, that is control value from output of the thermostat, is going to the actuators. You remember the closed loop controller, when the control error inserted in the PID controller, then the output is control value. So the output control value from the thermostat is going to the fan coil actuators, and it makes it work. You can see here, this is a fan coil on off, this is a control of the set point, this is a manual, and this is the fan coil special mode control. Of course it is possible for us to have the right status here, but this is only the example. In reality, in other devices, maybe you have the devices from Schneider Electric, from ABB, from other companies, almost they are the same, okay, but maybe it will be a bit different, but almost they are the same. So let's go and see about it. So this is a fan coil actuator unit. In this case, we have the digital input to get the input from the window contact, because we need system, if somebody open the window, the fan coil unit from the comfort change to the standby mode automatically to save the energy. About the fan, you can see here in a fan coil actuator, we should tell the fan coil actuator in our case, so is it 4 pipe or 2 pipe? Type of control, for example, we said we want to apply to the valve, you can change it to apply to the fan as you need. How many speed of the fan you needed? 3 speed, for example. In a fan part, as I told you, the relay management type should be interlock or accumulation. Of course, we have the pulse time for that. An important thing is, if you want to control the fan coil actuator manually or automatically, you should set it up for most of the time. And here you can see, to make it auto or manual, it needs some group object. So here with the group object, with the value 0 it changed to the automatic, with value 1 it changed to the manual. It should be the same from the keypad also. Great. So also here, in our case, in our device, for the data point time for fan coil control manual, it is written. We selected, do we need the enumeration, some number between 0 to 255, or percentage controller. Also, do we need the status object or not. Remember that from the fan coil actuator and keypad, these type of data point types should be the same to control the manual fan. You can see here, if you want to control the fan coil speed between the actuator and keypad, it should be in the same data point type. Enumeration, both of them, or percentage, both of them. And of course, because in this configuration here, we want to apply the control to the valve, we have the PWM control here. Okay, about the keypad, first of all, we should tell every button what to do. On off switch, fan speed control. In our case, we can have one button to control with the output of scaling 0 to 100%, to control speed 1, speed 2, speed 3, and also the mode, and so on, and also the set point. Okay, about the display, we can define it in detail. And about the thermostat, the inside closed loop controller. First of all, we should say to the thermostat it's going to control heat and cool. Here ask us the heat and cool automatic changeover when in our case is disabled, it means we have the separate group object to control heat and cool. Okay, it is possible in KNX devices to change the heat and cool for summer and winter automatically, but I prefer to change it by separate command. Okay, also here we tell the thermostat, the closed loop controller, how the temperature sensor data should become. Is it from the on temperature sensor or from the out source? Okay, so this is from temperature source 1. Later we will link it in the group addresses. Maybe in some product from some company it is linked internally and you don't need to change it anymore. For the set point, we have two options: absolute set point or relative set point to some reference set point. So I put it in absolute set point and continue with that. Okay, for heating, I want to control my system in the heating PI controller, proportional integral controller. Okay, and most of the time when you buy the thermostat from the company, this coefficient for P and I, proportional integral, is tuned by the company based on the application. So here, when I choose the blower convector, this 4.90 minutes is chosen by the manufacturer for PI coefficient, and it is optimized, and it makes our life easier, so we choose it. Okay, if you want to do it by yourself, you can go to advanced mode, but I prefer to choose it because, for example, I have a fan coil, I want to use it as a blower convector, and then that's it. I choose this one for heating and cooling. So this is the parameters. So what we have in the group addresses, we have several group addresses, subgroup addresses to control as a functional block to control the fan coil. One of them is on-off. Okay, you can see here the control fan coil. One of them is on-off. In my case, in on-off, I have the link between the group object from the fan coil actuator, thermostat, and keypad. Okay. Nowadays, many companies do not make the fan coil on-off. They only put it in protection way. Okay. So keep it in mind. For set point, the control fan coil set point, we have the group address, and it's going to link the group object from the set point from the thermostat side and the button in keypad. Okay, because you want to press some keypad to change the set point. But in some companies it is linked internally. Okay, so there is no need to link it anymore. For example, in Schneider it is linked internally. For mode between heat and cool, you remember in our case we have the separate group address to make the heat and cool. So this is done between the thermostat, fan coil actuator, and keypad because we want to change it by keypad. For manual fan speed, there is only the link between the button from the keypad and manual fan speed group object from the fan coil actuator. It is in enumeration time. You can see it's written here: 0 is speed 0, 1 is speed 1, 2 is speed 2, 3 is speed 3. Then we have the group address to change the manual auto, because when you do the change in manual fan speed, it is going to be in manual mode. So here you can see the manual fan speed, manual auto control. There is a link between the keypad and fan coil actuators. No thermostat here. Important group address, they are really important. We have 4 pipe fan coil actuators. Okay, so if you have 2 pipe, these 2 group address should be the same. So here we have 1 cooling and 1 heating value. Okay, so in cool value there is an output from the thermostat, to the input from the actuator, fan coil actuator for cool, and for the heat there's the heat output from the PI controller, from the thermostat, and input from the actuators. The data point type is a scaling some number between 0 to 100%. Okay, this is the status of the fan coil control. Of course, we have the status for the on-off between the display and thermostat. We have the status between the thermostat and display. We need it. Remember that in visualization, when you want to see the status of your fan coil, for each of them you should have these group addresses: on-off, set point, mode, heat, cool, fan speed. What is the fan speed? You have it. Okay, you can see here my status in fan speed is in scaling type. Okay, the control can be in enumeration, the status can be in scaling, or both of them can be the same. For auto manual also we have the status, we need it. Okay, so here, because we have we control the valve, if you want to show it in somewhere, we can have the status of the cooling valve and heating valve, if it is on or not. Important for temperature probe, there is a link between the internal probe. We have some temperature sensor in this device. Here we have temperature sensor. We link it inside between the temperature sensor and controller and thermostat. Okay. Also, we want to show it, so we put the group object from the display. In some companies' products, they are linked internally. There is no need for linking them. Also for window, as you see, this is possible to link between the input and window status, because we want to put it in a standby mode or comfort mode and display the situation of the window. After these at least 15 and more group addresses, you have the functional block to control the fan coil 3-speed 4-pipe in a right way. Okay, and also you can control it not only from the keypad but also from the other sources like monitoring systems. Thank you so much to listening to me. This is the end of part 2 of the HVAC control.